Hello, everyone, and welcome to the next episode of the Belinda Carr Show. Today, we're going to be talking about 3D printing again, but this time it's going to be a little bit different.
It's not just 3D printed concrete.
Exactly. It's 3D printed concrete used by engineers.
Yeah, it's also just a general material exploration into different things like geopolymers as well.
So, we're going to be talking to someone from Hyperion Robotics, and they are based in Finland, Helsinki, Finland.
How long have they been around?
I think around 2018, that's when all these 3D printing companies started around that time.
You actually made a video on 3D printed coral reefs, and that's one of the things that they do.
So according to their website, it seems like in 2019 and 2020, they started off like most other 3D printing companies. They were experimenting with furniture, column design, bridges, coral reefs. But over the past year or so, they finally hit their stride and figured out what they wanted to do. And it's structural exploration.
Yeah, it came in the form of concrete paddings or footings for large structures.
And it makes a lot of sense because if you look at their team, they're composed of mechanical engineers, structural engineers, a material scientist, and an architect who's also into parametric design. So they're like experts in their fields and they're coming at this from a very technical angle. It's not just design for the sake of design.
And optimize what the machine can do.
Exactly.
We've talked about that with a few different of these 3D printed companies like Saga and Vertigo and even 20 Additive. Whenever we visited them in Canada, they had a few examples of ways that they were trying to minimize thermal bridging in one of their walls that they printed. And it's just all these different explorations with the 3D printer of what it can do. So now we have trained engineers exploring what this can do. And I feel like they've really hit their stride with this padding design. And what exactly is it about their pad design that works?
So it seems like there's this infrastructure company that reached out to them and said, hey, typical pad design is just a cube of solid concrete. Is there something you can do that is better than that? So they designed this optimized pad that uses 75% less concrete, 50% less time, how about that, and up to 90% less carbon dioxide emission.
I think it was achieved by using parametric design, as we spoke about in a previous episode.
So they used concrete exactly where it needed to be used rather than just pour concrete into a formwork and dump it into the ground. So much lighter structure. It's only using it where needed.
The cube pad design is really overkill. It's more than you need, but it's not easy to make a structure, a pad design like this. And so that's where the 3D printer comes in. They can just program it into the computer, set up the machine, and print it. And they actually print these off-site, don't they? They print them in their factory, and then they bring them on-site, I think.
I think they're trying to do both. That they might have done this in their factory, but they use a robot arm rather than a gantry system because of the scale of their project. It's much smaller. So they want to deploy these robot arms to job sites around the world and then print it locally so that you're saving on shipment.
Yeah, that's one of the things on their website is the sell and the lease of micro factories. So it's a truck that comes with the robot arm and they can actually print on site.
And the good thing is that robot arms are basically available in most countries. You can also just buy a robot arm locally and then maybe buy their nozzle head or their concrete mixes and then print what you want.
Yeah, so to be clear, they don't actually make the robot. They actually get the robot arm from a different company. They use the KUKA, K-U-K-A
yes.
robot. But what you're getting from them is their engineering expertise and their specific designs that optimize the machine and the use of the material.
And they're also into material research.
Yes.
So they're already diving into geopolymers and other materials that are not just motor mixes. They're also looking at how they can incorporate industrial waste into these 3D printed concrete structures. They're looking at mining waste, steel waste, wood, coal, and concrete waste.
Yeah, any way to upcycle this and utilize it with the 3D printer.
And that's great. I love it when companies like Hyperion tackle building problems intelligently. Like they not using a 3D printer to just print a box.
Walls per house.
They're saying, what can we do with this that we couldn't have done before the invention of this machine?
It sounds like something architecture students would do. It's that very exploratory, motivated.
I think the fact that they are engineers and not just architects makes them different.
Yeah, they're not looking at how to make a nice curved column because that's been done, and they're more concerned about how much material actually needs to be used in a column. How thin can we make it? How much material can we save? How can we use something? How can we upcycle something and it still be as structurally sound as a regular column?
So I spoke to their material scientists to learn how Hyperion is using 3D printing technology for infrastructure projects. So today we have Ashish Mohite, co-founder and CTO of Hyperion Robotics in Helsinki, Finland. Thanks for joining us, Ashish.
Thank you for having me.
So could you tell us a little bit about the people in your company and what backgrounds you all come from?
Yeah, so I'm the CTO and co-founder. My background is in architecture. So I'm an architect. I have bachelor's, master's, and PhD in architecture. And I have been doing research in 3D printing for last 10 years in Aalto University. My co-founder and CEO, Fernando, his background is from business. We have the third co-founder, Henry, who is a structural engineer who worked with Arup, the structural engineering firm, for last 8 years. And then the fourth co-founder, Wycliffe, is a mechanical engineer and has been working in the mechanical engineering field for past decade. So this is a very diverse background and experience from different fields. But yeah, what we like to call ourselves special because we are architects and engineers, structural engineers. So we understand construction very well, both from the design point of view and structural point of view. And this is what we try to do in our projects.
Yeah, it's very different than other 3D printing companies I've spoken to because they might come from a tech background, not necessarily from a design and engineering background. So how has your collective experience affected the projects that you all are involved in? I know you all designed some very material optimized and structurally optimized pads.
Yeah, so the foundation project, which is on our website. So first of all, to start with, like even just with 3D printing technology, complexity is for free. This is what we call in 3D printing technology. This is also what I teach to students. Complexity is for free. And then when it is a possibility to actually optimize the structures structurally and topologically, then we try to do it because that's actually taking like really core advantage of the technology, what it allows you to do. And so you can see in this case of foundation, the typical pad foundation is a cube. If we just wanted to 3D print that, we could have just printed a cube and casted the cube, but we put on our thinking hats and started thinking like how we can technologically use this technology and use the advantage of the technology and optimize it. So Henry, who is a structural engineer, worked with the engineers from our clients, got all the numbers, the structural numbers, the load cases. And based on that, and based on his experience in structural engineering, he came up with this kind of optimized design, so which was supposed to perform the same as their traditional technology. And then when we tested that, it performed 3 times better. So this was a surprise to the client, not to us, because we knew that it was supposed to perform a particular way, but it actually performed better than what we expected. So this was a proof of concept that yes, you can first of all topologically optimize structures. And the second is 3D printed structures can perform the same way as traditionally casted structures.
So could you explain how you all achieved that 75% material efficiency in the footing design and what exactly you all are using that for?
Yeah, so this project was done for an energy company called as Iberdrola. And Iberdrola had a startup competition where they asked us like how our technology can influence or can help them build better, more sustainably. And we worked with their engineers to figure out where they are using concrete structures. So this is an energy company. So energy company builds a lot of energy infrastructure. So we came up with an idea of like how So they built wind turbine installation. So every wind turbine, there is a substation, and every substation has like around 50 pad foundations, which are right now they make it out of cubical casting. So they just like make a cast, a mold which is cube, and then just pour concrete, because that's the most efficient way to do that foundation. So we thought like, okay, but like with 3D printing, we could actually optimize that design and can achieve the same structural performance which is needed. So Henry, my co-founder, who's a structural engineer, came up with first. He worked with the engineers, so from Iberdrola, from the client side, with all their structural needs, and then he created this geometry which was optimized to achieve the same structural results, but to use a minimum amount of material. So this particular foundation specifically can use 75% less material. There are other foundations which use 50% less material. There are others which can also use less material, which is 80%. So this was the one which was chosen because this was an average size of the foundation. It was 1.4 meter by 1.4 meter by 1 meter. And it was supposed to perform in a certain way. So we also did like a pull-out test. We have the video on YouTube about that. So it was supposed to perform and break at 1 ton, and it broke at 2.7 tons. So it performed 3 times better than it was supposed to perform. So that was a validation that, first of all, you can reduce the amount of material which can be used. B, that it can perform the same way as like normal casted concrete structures perform. And yeah, so this is like the main question again, always with concrete 3D printing, everybody has that, is it going to perform the same way as like normal casted concrete structures will? And this was a proof of concept, basically.
So is that an idea y'all are going to run with in future designs, that sort of material efficiency?
Yes, because this is how we see, first of all, to use the potential of the technology. And this is where the clients also see, first of all, in terms of savings in material, but also in terms of CO2 savings, because as we are all going and building a new sustainable world, the CO2 impact becomes a very big role here.
So what are your next projects?
So most of our projects right now, we are working with few clients. All of them are industrial clients. So we are focusing on industrial infrastructure at this point. So industrial infrastructure means everything which needs, everything which is not a built environment. So everything which is not occupied by humans, but everything which is, let's say, foundations, culverts, trenches, big silos, big tanks, which store material matter, and which also like allows matter to move from one point to another point. So this is something which we have realized is there is a big market, first of all, and this is where we think that we can provide the best value at this point.
That's what y'all are trying to focus on.
Exactly.
So is that one of the reasons why y'all have a robot arm rather than a gantry system, like most other
Yes.
3D printers, 3D printing
Yes.
companies?
Yes, that was the reason why we chose a robotic arm. Was first of all the reliability of the system, so you don't have to really worry about anything mechanical. The movement part is most of the times is taken care of. It's very easy to install, fast to install, and all these sites which we're talking about are also very remote. So what is important is how can you efficiently move the printer or the printing system to a site, and how you can disassemble it and like move it to the next site. And this is where we found that the robotic arm systems are, first of all, very reliable. Second of all, because we have clients around the world, we can also always source a robot locally. So we don't have to ship any system from Europe to all the way to South America. And we can always get the support locally if anything goes wrong with the robot. You know, you like Kuka, the robot which we are using has supports all around the world. So that was one of the reasons which we are using that. There are size limitations, of course, but until now we haven't faced anything where we would need to have certain other systems.
Because most of your projects are on a smaller scale.
Most of our projects are at a smaller scale. Like the largest what we have printed, which was yesterday, was 2 meter by 2 meter by 2 meter silo, and that was actually 3D printed by using geopolymer. So geopolymer, that to just add water geopolymer. So it performs the same way as normal mortar. So it is a dry mortar. Just add water, and it performs exactly the same way. So we didn't even have to use different pumping equipment, or we didn't have to make any kind of new equipment. And it's 97% recycled. So even the aggregates are recycled from mining tailing, so like mining waste. And of course, the binder is also recycled. So the only 3% which is not recycled is the alkali activator. That part is not recycled, but everything else is recycled. And the carbon footprint for 1 ton of that material is 15 kilograms. So
Wow.
it's less than wood. So
I'm very fascinated with geopolymers, but I unfortunately don't know enough about them. I still have to look into it. How did y'all get into that area? Are you teaming up with some universities in Helsinki?
no, so this also project came through a client. So there is a client who I cannot name. Is an industrial company, and they are in the sector, in the mining sector. So they are facing this kind of huge problem, which the mining sector on whole world faces actually. Now we have 400 billion tons of mining tailings around the world. 400, that's a ridiculous amount of mining tailing, which is just in this kind of like very large ponds
Okay.
with a lot of water. And this all can be used as aggregate. Of course, there needs to be some kind of post processing to be done, but after that it's exactly performs as aggregate. So you can actually replace a sand, like by using mining tailing, because sand is also a big problem, as you know, that
Yes.
sand is the most mined material on the planet, and we are running out of sand. Like China is importing sand from Africa. So we need to solve the problem of sand. We need to solve the problem of cement. So how do you solve it is creating new kind of geopolymer or like alkali activated material by not using cement and by not using sand.
Do you think 3D printing is one of the like ideal tools we can use to explore this area of geopolymers?
Yes, I believe so, because because we are at the cusp of this kind of new technology, which also gives us this freedom that when all these companies are designing these new inks or new 3D printed mortar, why not create a completely new mortar which is recycled, at 97% recycled? So this is like the perfect opportunity to explore new type of materials, to see what kind of sustainable sources which we can source the material from, and reduce our dependencies on really carbon intensive materials.
Are there any structural concerns when using geopolymers?
There are. So right now, the only thing which we can guarantee is the compressive strength, because this is something which we have tested. But all other tests, freeze and thaw, chloride ion, all this has to be still performed. So this will take some time for this material to be used commercially in a scale where it can be used. But we have to start somewhere.
So, how are the do you think the officials in Helsinki and in Finland are supportive in your material exploration? Is there a lot of red tape?
Well, as you know, the construction industry is a very conservative industry, and
Yeah.
it is right to be conservative,
Yeah.
because in the end we are building
Lives
structures
at
where
risk.
human
Yeah.
lives are at risk. So yes, of course it will take some time to change that. But yeah, like as Finland is part of European Union, in the European Union there are certain codes which are standardized. So if we actually comply with certain codes in Finland, though it would be easier for us to comply with other European countries with certain changes or certain additional tests which are required. But let's say 80% of compliance can be done in one European country, and then the same material then can be used in other European countries. So that's another advantage of like being in European Union. And the Eurocode is quite clear about like when you are exploring new material, there are certain codifications which are already existing, and then if you pass those tests in those kind of accredited labs, then yes, one thing is to get it all certified, another thing is to convince a client to actually use it. So this is going to be a long road, that we know, but this is something we have just started.
Are you all working with any code officials on getting these new geopolymers and all these new products approved?
Yeah, so for a previous project where we actually developed again another mortar using waste material from paper pulp industry. So that was also 100% waste from a paper pulp factory, both aggregate and binder. And in that case, we were using organization called as Eurofins, which is also another umbrella organization. So Eurofins Finland, there is also Eurofins Spain, and we try to get all our compression test results certified by them. So if Eurofins certifies that, then like it can be accepted everywhere else in Europe.
So you said sorry, continue.
No. So what we do is like we do in-house testing. Once we are satisfied, at least the compression, tensile and flexible test. And once we are satisfied, then we go to Eurofins and then like try to do the test and then see the results and like then get certified.
Okay. And you said you all have projects around the world. You said in South America too.
Yes.
Are those also like structural projects that you are building, like not just houses?
No. So we do not have any project right now to build houses. So all of them are to do with structures, which are to do with infrastructure. So like what we said, what I said, like Iberdrola is a Spanish company, but it's a global company. It's the second largest renewable energy company in the world, who has operations globally in US, in South America, in Scotland. So there also the idea was that we'll create this kind of a microfactory idea. So this microfactory, and then we will test this microfactory at a pilot stage. And if it works, then this microfactory will travel from their one site to another site to another site. Just to give you an example, like Iberdrola has 10 kind of sites just in Scotland every year to do this kind of substation. So 10 substations every year they do. And then the second company which we are working with is Argentina-based company, who also have projects around Central America and South America. So the idea again is that to create this kind of microfactory, which you can execute one project on one site and then move to one site to another site and build infrastructure elements. So we are working with global companies which have global footprints. So we try to do one pilot project somewhere and test that idea. And then that pilot project or this microfactory then can transfer to other countries and perform the same projects.
So that makes sense why your team is so small, because y'all are really focused on the design, and y'all need special, like y'all come from an engineering background, and y'all are developing all these like specialized designs that you don't need a large team for production. It's more on the design side, right?
Exactly. So at the core, we are a technology company. So we are trying to provide this technology and enable this kind of large infrastructure building construction companies to execute their projects and first of all, reduce the carbon footprint, reduce the cost, and increase efficiency. So this is what we are trying to do in a nutshell.
So the robots that you all use you'll buy them from another company. You said KUKA?
Yeah, KUKA. So KUKA is a German robotics company which makes robots for like, car factories, machineries, and things like that.
And y'all have just adapted it to use for 3D printing.
Yeah, so like I like to, because I also teach in university, I like to explain the robotic arm as a human hand, right? And then you just have to give it a tool. So in this case, the tool is concrete 3D printing nozzle. So this can be also adapted to do something else, but in our specific case, we do concrete 3D printing.
And do y'all make your own 3D printing nozzles in-house?
Yeah, so this is something which we do. So the whole automation, the 3D printing nozzle, the connection between the robot and the nozzle and the pump. So this is something what we do, and all this knowledge of like what should be the layer height, what should be the setting time, how fast the robot should move, what should be the layer thickness. All this is something which we are developing, which is in-house knowledge, and this is something then we have to transfer it to our clients.
Okay, and you said you teach at college too, so you're kind of spreading all the knowledge you've gained at your company at Hyperion to all the students. Do you see a lot of interest in younger people?
Yeah, so I used to teach also, like I have been teaching since 2010 on and off. I teach some courses and in here in Alto, I'm mostly involved teaching 3D printing, right? So the whole idea of the courses which I design or teach is to create interest into students of using how they can use the technology to design, to execute, and to create their projects.
So are you
developing? Not to just create like sorry, not to just create like final model of your object, but like to use them as a tool.
Yeah, you think about the tool more critically and not just, like you said, you do everything that we have been doing for the past 1,000 years. But now that we have a new tool, design it differently and use new materials and actually rethink the wheel, basically.
Yeah, that's also was my PhD topic. So in my PhD, this is also what I did is I was actually exploring uh, idea of craft and how can machine create craft. And so I also did a lot of 3D printing. My whole PhD was about 3D printing using different techniques and technologies, but at core is trying to explore how this could be a new kind of design tool itself. The technology can be a design tool.
So where do you see the Hyperion heading in the next year, in the next 5 years?
Well, we have done now few pilot projects with these companies. So now the next is to set up this kind of micro factory on site and to do scaled up project production. So let's say like now we are doing 1 or 2 objects, but we want to do 20 objects or 100 objects, like 100 foundations on one side. So that would be the next stage to scale up.
Okay, is there anything else you'd like to discuss about your company or your projects?
Well, I don't know, like I think for me, as always, like in every 3D printing technology, just from my experience in academia and doing research in 3D printing, the material is the key. This I always believe that, and I still believe that the material is always the key. And even in other 3D printing technology, most of the inventions or most of the newness is coming from development of materials. And this is something which I think is going to influence a lot in the future. And we have to think, as I said also before, that we have to think about sustainability. And we have the opportunity right now to actually rethink the way we use the materials.
Yeah.
Because yeah, we have very finite resources. I always like to talk about that because you know that we only have 50 years of limestone in the world. So after 50
Really?
years we won't be after 50 years we won't be able to get any cement. So we have to think about future, right? Because we have to think about the next generation, what's going to happen. And if the pace of construction keeps on going the way it is going, and our reliance on cement keeps on increasing, then even we have less time. And then I already talked about sand. So we are also running out of sand. So if the cement and sand is not there, then what do we do? So we have to start thinking like what would be the replacement material.
Yeah, we have to start thinking about that now. I didn't know that 50 years of limestone left in the world. I didn't know that.
Exactly. So yeah, if we don't start mining the oceans, then yes,
Oh, wow. Okay.
because oceans have a lot of limestone. But yeah, this is something which we should not be doing.
Okay, thank you so much, Ashish, for sharing all that info with us. I really appreciate it.
Thank you.
So Ashish outlined a little bit of what Hyperion's been up to and what their future holds, but I'd really be interested to have a much more in-depth discussion with him and their whole team and what they're doing in Finland.
Yeah, so I hope we get to go to Finland pretty soon. I actually reached out to him a couple of weeks ago and said, hey, if you're going to visit Finland, can we talk to the other people that you know around Finland? And he gave me a whole list of companies in Norway and Sweden that he has connections with.
Are they 3D printing companies?
They're not, no, but there's Aalto University in Finland that they are doing regular materials research with. There's Safe Rock and Snowheader and Reforstech that makes rebars out of basalt rock.
Oh, so different companies that are exploring different ways to use material.
But all in the infrastructure, industrial field.
So less about like home construction.
Yeah.
And that seems to be where 3D printing is stuck right now. You got these big companies out there that are stuck on building homes and thinking that that's what 3D printing is for. It's going to solve homelessness. Well, maybe it's more of it's going to provide more efficient concrete paddings for all of our roads around the world.
That's a very good point. It's like maybe this buildings are not the best application for it.
Yeah, it's nice to see someone looking at this from a infrastructure perspective.
And it's so easy to just get sucked into building houses or building At least in the States, it seems like there's a lot of money in the affordable housing field, like proposing cheap, affordable homeless shelters using a 3D printer because it looks cool. But these people have said, no, you know what? We have found clients that want to use 3D printers for that particular application. We're going to run with that.
Who's to say that 3D printers are supposed to be used for architecture? And then I think about old-fashioned plastic printers and what the majority of people use those for, and how they seem to be very underutilized because people just go to Thingiverse and find what they want and just print that. And it's some sort of like little character that they want to sit on their desk, as opposed to using that plastic printer to make joints or make brackets or something. So we used the 3D printer to make little clips for our windows because those pieces had broken off. And I felt like that was a great application for them. We used them to make caps for our Unistrut, as opposed to just printing a little character and putting it on your
or
desk.
A boat, because everyone starts out by printing a boat. So there's this guy on Instagram, Matt Benedetto, I think. So he runs an Instagram page called Unnecessary Inventions. I think I've told you about him before.
Yeah, you've shown me that.
Incredible. Just his imagination, his creativity is out of this world. So the way he uses 3D printers is awesome. So he invents something new every week that solves an unnecessary problem, a problem that doesn't exist. But he is not just going on Thingiverse and downloading something. He designs it and uses a 3D printer to turn that idea into reality. That is incredible.
And I'd love to see that application applied to concrete 3D printers. And that's what Hyperion's looking at. So I feel like we've gone full circle with these 3D printing companies. I mean, we started with one that does houses, and then ones that develop and dig more into furniture and space design, designing for Mars. And now we're to the point where they're looking at infrastructure uses for a 3D printer. I mean, it can do so many different things. And I feel like we've learned a lot.
So the next stage is to talk to someone who's actually visited all those companies and more all around the world, and that's Jared Gross. So he's visited almost every 3D printing company around the world, and he posts videos on his YouTube page regularly. So he's coming over to our studio next week for our first face-to-face.
An in-person podcast.
Yeah. We met him in Austin last year. He invited us to stay at Icon's 3D printed house, which is very sweet of him.
So it'll be interesting to have him on the podcast because he has knowledge from all around the world of all these different 3D printing companies. And perhaps he can give us some insight on a few others like Hyperion that are doing very unique experiments.
So I hope you enjoyed our discussion on 3D printed concrete in the infrastructure industry. Join us next week for another episode on building science, products, and technology.